Good morning, everyone. My name is Christy Richter, and I am the Southwest Regional Technical Representative for Arborjet. And I'm going to be talking to you today about invasive shot-hole borer and similar pests that we are dealing with here in Southern California. So polyphagous shot-hole borer is an exotic invasive wood-boring beetle that carries three fungal symbionts: Fusarium euwallaceae, Graphium euwallaceae, and Paracrimium pembium. Sometimes those are very difficult to pronounce. Kuroshio shot-hole borer is an identically similar Good morning. My name is Christy Richter, and I am the Southwest Regional Technical Representative for Arborjet. I am here today to talk with you about an invasive shot-hole borer that is invading Southern California and causing a lot of damage to our canopy here. So, polyphagous shot-hole borer, Euwallaceae species number 1, is an exotic invasive wood-boring beetle that carries three fungal symbionts: Fusarium euwallaceae, Graphium euwallaceae, and Paracrimium pembium. Kuroshio shot-hole borer is a physically identical ambrosia beetle that can only be differentiated by its DNA sequence. It carries a different species of the Fusarium and Graphium fungi that causes Fusarium dieback. This species was actually detected in avocado trees in San Diego. So the ambrosia beetle came from Southeast Asia. We will be referring to it as invasive shot-hole borer. So even though there's two species, we will refer to it as invasive shot-hole borer at this time. It was found in Whittier Narrows in 2013 and believed to have been brought in at the Port of Long Beach. It actually spread through there and killed all of the box elder trees in a very short period of time. In 2012, it was found attacking avocado trees. Hi, my name is Christy Richter, and I am the Southwest Regional Technical Representative for Arborjet, and I am here to talk with you today about an invasive insect species that is here in our area and is killing a large amount of trees in our urban canopies, and it's changing our urban canopy rather dramatically at this point. So, to give you a little background, polyphagous shot-hole borer, its name is Euwallaceae. Species number 1 is an exotic invasive wood-boring beetle that carries three fungal symbionts: Fusarium euwallaceae, Graphium euwallaceae, and Paracrimium pembium. Kuroshio shot-hole borer is a physically identical ambrosia beetle. It can only be differentiated by the DNA. It also carries Fusarium and Graphium fungus, and those fungus cause Fusarium dieback in our trees. So it's an ambrosia beetle that came from Southeast Asia. We will be referring to it as invasive shot-hole borer, or ISHB. It was initially found in Whittier Narrows in 2013, and it was misidentified at that time as a T shot-hole borer. It killed all of the box elder trees in that particular area at that time. It's believed to have been brought in through the Port of Long Beach there. We didn't really start paying attention to it until it was found attacking an avocado grove in Escondido in 2012. That's when everyone started to realize that it had been misidentified and that this was, in fact, a very detrimental species to our crop industry and then, of course, to our urban canopy as well. Currently, the species has now been found in Orange, Ventura, Riverside, San Bernardino, San Diego, Santa Barbara, and San Luis Obispo counties. It is known to have attacked over 300 different species of trees. The invasive shot-hole borer also carries several different fungi, including a Fusarium that is disease-causing to susceptible trees. This is an image of what the polyphagous shot-hole borer looks like. You will notice that the female is actually much larger than the male. You can see it there. And this insect has literally killed thousands of severely infected trees in our both urban landscape and riparian areas. There's an area down by the Tijuana River Valley where we lost over 120,000 trees in less than a 9-month period. So the population explosions are causing a lot of damage. So what exactly happens when the beetles attack? Because just because it's attacking a tree does not necessarily mean that it is going to kill that particular tree. So we do have scenarios where beetles are repelled with no infection, and this has been noted in 20 tree species. We also have scenarios where the beetles are actually able to tunnel into the tree and plant the Fusarium that they feed on. And what differentiates this particular scenario is that they are not able to actually produce offspring in the tree. So the third thing that can happen is that the beetles would tunnel into the tree, be able to plant and grow that fungus, and be able to produce offspring in that same host species. And this has actually been observed to happen in about 8% of the tree species that they have attacked. Currently, there are 64 known reproductive hosts. Again, a reproductive host is a beetle that can tunnel into the tree, plant and grow the fungus, and produce the offspring. 31 of these trees are native to Southern California. Currently, there are only 15 species of trees on the reproductive host list found to be attacked by Hiroshio shot-hole borer. Does that mean that it is not able to attack and infest the same number of trees and the same species of trees? No. The truth is that this is expanding on a regular basis. They are continuing to do research and track this insect species throughout Southern California. So those numbers change dramatically in just a short amount of time. So how does this insect actually produce? It takes about a week for the female to tunnel into the xylem tissue of the tree. Again, this is not a cambial feeding insect. It will tunnel into the sapwood, where it plants the fungus on the walls of the tunnel as it goes. Then the female, once completing that tunnel, will lay eggs at the end of that tunnel and back herself up with her abdomen protruding from the entry hole. That protects those eggs from any secondary invaders that come through. Once those eggs hatch, they will actually mate inside those galleries, and then they will feed on that Fusarium. And in about a month, they will actually emerge, walk over an inch or two, and go right back into the tree. So between the combination of the amount of reproductivity as far as the number of insects and the combination of that with the Fusarium, trees actually become under heavy attack in a very short amount of time. These are very lazy insects. Even though they do fly, only the females fly, and they fly very short distances. So we found that on windy days, that's probably the farthest distances that they would fly be carried on the wind. Otherwise, they're going to be very lazy, and they're going to infect one tree and slowly move out from there. This is an example of what the Fusarium euwallaceae looks like. If you notice the little galleries that are kind of lined in between there, and you can see the black that lines those galleries, and that black lining is actually the Fusarium that they feed on. In the picture on the top left there, you can actually see the Fusarium fungus as well as the Graphium fungus growing in there. So one of the ways you can tell if a tree is actually susceptible to the Fusarium and is going to be infected by it is simply by removing a small bit of the bark surface off of the tree around one of the entry holes. And if you see that little black area there, that's how you know that there's Fusarium in that tree, growing in that tree. It does clog cells, and it disrupts the flow of water and nutrients up the tree, thereby causing branches to die and will eventually lead to death of the tree once the infection becomes large enough. So what are we looking for when we are looking for actual signs and symptoms so we can diagnose this? As you can see there, the entry holes are perfectly round. They're very small, about 1 millimeter in size. And if you take the tip of your pen, as shown in the photo there, you actually will be about the size of that site. All trees will actually display differently. So they exude different types of sap and exudates and things of that nature. So just because it looks one way on one tree, don't expect it to look the same on another tree. So another one of the signs, obviously, is the exudate that comes out of the tree. Sometimes it's brass, sometimes it's powdery, sometimes it's thick, sometimes it's wet. So you just be aware that that is definitely a symptom of the fungal disease in there. And then, of course, you would see dieback and dead branches with wilting leaves, and that's actually a sign of severe infection from Fusarium, again, with the cells being clogged and not able to transport water and nutrients up that tree. So this is causing a very large environmental impact in our areas here to the just because of the loss of the amount of trees and damage that this insect does. And so it's a public safety hazard due to falling limbs and failing trees, additional fire and flood risk, loss of our ecosystem services, decreased property values and increased air and noise pollution, and of course habitat loss. So our trees play a very significant role in our everyday lives. Currently, this is the distribution map of this particular insect. So you can see Long Beach, the little blue dot there in Long Beach. That's where it was initially found in 2003. That is actually Curotius shot-hole borer. They're not sure where the polyphagus came in, but it is believed that it came through, again, on shipping containers. You can see how this insect is actually spread out through our valleys here in Southern California. The polyphagus shot-hole borer is now, again, starting to intermingle with the Curotius shot-hole borer. Either way, again, without DNA, they're not going to always know which particular one of these species that we're dealing with. But, again, it is an invasive shot-hole borer, and between the insect spread and the Fusarium spread, it will eventually kill trees. So all the little yellow, diamonds there are just to detect shot-hole borer, not specifically to the Curotius or the polyphagus shot-hole borer. So this is just kind of a general idea of the net economic cost analysis of what is happening in Southern California. Basically, what we looked at is what would happen if 50% of our host trees dies. And remember, that's not all the species being attacked. Those are the reproductive host trees. So if 50% of those trees died, the cost of removing and replacing just those trees alone would be in the $15.9 billion US. The ecosystem services lost $616.8 million annually. And then we're looking at $12 billion over 20 years. And again, that's 50% of the host trees only. 80% of the host trees die, then cost of removal and replacement would be closer to $25.4 billion. And then our ecosystem services lost would be in the range of $987 million a year, which is $20 billion over a 20-year period. So there is significant economic impact just to remove and replace trees. That's not the impact of anything else that's happening because of that removal. So what can we do? So back in 2012, 2013, Arborjet became very involved. We started learning about this insect and got in contact with some of the local professionals known to be the top researchers on this particular insect. And so we were able to actually start some therapeutic and preventative trials in areas that we were finding a lot of active pest pressure. The first trial that we put together was actually a therapeutic trial. In other words, we were looking at trees with a light to moderate level of infestation. The way we decided how infested the level was on the tree is we would simply square off about a 12-inch by 12-inch section of the tree at about breast height on the north side of the tree. It seemed that the insect at that time was more prone to attack the north side of the tree, and so we were looking for areas that were the most infested at that time so that we could get a legitimate research study going. So we would go ahead and count the number of attacks in that 12-inch by 12-inch area, and that would help us decide whether this was a light or moderate level of infestation, or if it was potentially too severe to do any type of treatment at the time. So we were looking to report the potential efficacy of systemic injections using a product called emamectin benzoate and a fungicide called propiconazole. Emamectin benzoate has been known to be very effective against wood-boring beetles, and so we wanted to have a study that was a little different than the studies with products that have been known to work on different insects and are very widely used. So what we did is we evaluated 100 sycamore trees at Pasadena Glen. Again, for the level of attack, the size of the tree, and where the tree was actually located. 30 trees were selected for this particular trial. 20 trees were treated with emamectin benzoate alone, and 10 trees were selected and treated with emamectin benzoate and propiconazole. The last 10 trees were not treated with any chemicals. They were the untreated check trees. So we could monitor the level of attack and pest pressure in the area. Applications were made in March of 2013, and then they were reapplied in March of 2015. We then evaluated those trees every 1 and 6 months, at 1 and 6 month intervals to measure the health conditions. The second trial we started was started in 2014, and this is actually a preventative trial. We were actually looking for trees that had little to no level of attack present, but we did want to make sure we were in areas that had pest pressure. So again, the object of this was to report the efficacy of the emamectin benzoate and the fungicide used as a preventative treatment of the California sycamores against this insect and disease. So in this particular trial, we chose 80 trees at Caltech University, 80 trees at Pomona Fairplex, and 36 trees at the Rose Bowl. Each of these areas had 4 treatments. The first being the emamectin benzoate by itself. The second treatment was the propiconazole by itself. The third treatment was the emamectin benzoate and the propiconazole together. And the last treatment was actually the untreated check trees. These applications were made in January of 2014. And again, they were reevaluated at 1- and 6-month intervals to measure the condition of the trees. So we actually did a visual determination of the ambrosia beetle and the fungal activity on sycamores. This is what we were looking for. The wet sites on the left were considered active sites. And you can see we put a little non-acrylic paint over the sites to help us determine whether we had wet or dry activity going on once those trees were treated. So the sites on the right-hand side are considered inactive sites. They're no longer oozing. So that's how we differentiated between the 2 types of attacks, one being active, one being inactive. So an evaluation was done, and again, we chose the north side of the tree. And in these particular trials, we actually did a 6-foot height from the ground to the top of the tree. And we would then count the number of bleeding attacks and the number of dry attacks each time we went back. Each time we also marked all these sites so that we know which ones had been counted in previous evaluations, so that we can keep an accurate count of the level of activity. And lastly, the number of surviving trees over time throughout these sites. What was seen in the therapeutic trial is the emamectin benzoate had some good efficacy during certain times of year against the beetle attack. The propiconazole showed good results for being able to reduce the level of Fusarium growing in the tree. And then you can see there the untreated checks and kind of what line that follows as well. So here's another grid here where we're just showing again the number of wet or active sites and the number of dry or inactive sites. And you can definitely see a significant difference in a reduction between the treated trees and the untreated trees, but more so the trees that were treated with the emamectin benzoate and the propiconazole definitely were more effective than just treating with emamectin benzoate alone in this particular therapeutic trial. Again, active light to medium attack levels on these particular trees. So in the preventative trial, what we found in the preventative trial is that throughout all of the treatments, the level of attack varied greatly in a few of the sites, which basically tells us the pest pressure is definitely different in those particular sites during different times of this particular trial. So if we actually break all of those down for the preventative trial, you can see there the untreated checks, and in some areas those actually were, again, higher level of activity going on. We see that the propiconazole was able to effectively slow the fungicide down, or the fungus down, sorry, and then the emamectin benzoate also did a significant job in reducing the amount of attack. But overall, the best combination was when we used both the emamectin benzoate and the propiconazole. Even though some of these trees had not previously been attacked, we still found that the combination of the two worked much better than than just using one or the other. So this is another trial that we did, and with this particular trial, we used the highest level of triage according to label to go ahead and treat these trees. And basically, these were done on sycamore, maple, and sweetgum trees. And what is significant about this is that the only tree that was lost between in any of the treated trees was the Japanese maple. They did lose one during this particular trial. Other than that, the treated trees, both in the sweetgum and California sycamore, were able to be protective effectively against the insect and the fungus. So what does it tell us? Basically, it tells us that triage alone is shown to be effectively reduce the amount of colonization by this insect on California sycamores. But the combination of triage and propofol together has shown to be more effective when we are dealing with trees that are light to moderately infested. One of the key things about this particular insect is we need to make sure that we are doing proper sanitation. In other words, removing highly infested and dying trees as soon as possible. One of the really important things with that is that chipping is required to be less than 1 inch in diameter to effectively control transporting the insect. And this is through many, many studies that the universities have done. It is stated that if you are not able to get rid of this trash from this from the wood, that you actually leave it on site so that you're not moving it around to infest other areas. There has been different types of solarization that they have attempted, and most recently they came back and stated that the only effective thing that they're finding now is an actual metal type of screen over the top of your debris. Solarization as far as plastic sheeting does not work because this particular insect will chew through it. So again, it's very important to make sure you are disposing of the highly infested material from the trees in an effective manner so that you're not spreading this. This is our current label on our Triage G4, which is 4% emamectin benzoate. This is up here because we are the first, and as far as I know, still the only company who has a label that is specific to being able to treat for polyphagous shot hole borer. And basically what that means is that the state of California agreed with our research that emamectin benzoate did effectively reduce colonization and the activity level of this insect. We also have expanded labels for our propiconazole product, which is called propofol, and it is listed on the 2EE expanded label to be able to control the Fusarium dieback of trees, including western sycamore, for Fusarium euwallaceae. This other 2EE expanded label is for our original triage product. The reason I have these particular labels up here is so that you know that they are there, and if you are listing this disease or insect as a treatment for reporting, you need to make sure that you have these expanded labels with you so that you are following all the guidelines. This here is a suggested treatment chart that we have put together due to the results of the research of our products. And so one of the biggest things that I like to point out on this, obviously if there are no attacks observed on a tree, you can treat preventatively with our lower dose of triage. This kind of gives you a breakdown of what it will cost to do those treatments. The other thing that I really want to point out on here is that when you get into any level of attack and you look at this chart And between 21 and 22 diameter inches, the label rate literally doubles the amount of product that you need to put in the tree. So whether it's a lightly infested or a moderately infested tree, you still want to jump up and use those higher rates. And the reason being is we need to make sure that we are able to thoroughly get material throughout the entire canopy of the tree. And as we grow in trunk diameter, our canopies will grow many, many times faster than the diameter of the tree. So that's the reason for the jump in that particular treatment application. So I'd like to also talk to you guys a little bit about similar looking pests and symptoms in the area. And again, you know, diagnosis is so important. We want to make sure that we're able to track this particular insect and see where it's expanding to so that we can help educate and make sure that we're getting good information out to the public so that hopefully we can slow the expansion of this insect. So golden spotted oak borer has been found in California recently, and it's actually a native species to Arizona, and it is believed to have been brought over on firewood, oak trees. So believe it or not, they believe that's the way it's been transported into our counties here. And it is actually causing damage to a lot of our California oaks. And unfortunately, it's a lot of our large, 200-300-year-old oak trees. The difference with this is that the exit holes are actually D-shaped. It's very distinct. They are not round. And so it's very easy to actually identify this particular exit hole for this insect. So the female will actually lay her eggs in the bark of this tree. They lay it around the base or in the bark, and then the larva will tunnel in and feed on the cambial tissue, thereby disrupting water flow and nutrient flow up to the tree. We have found it to be attacking coast live oak, canyon oak, and California black oak. Initially, it was found in the eastern San Diego County area, but has been found now in Riverside and some of the riparian areas up in Muir Canyon, which is up in northern LA counties. So another one that is on the rise. Western oak bark beetle. This is actually confused down here a lot with polyphagous shothole borer, and it is because it's a small round entry hole, but the truth of the matter is that it's actually smaller than polyphagous shothole borer. They tend to cause a light-colored frass around their entry and exit holes on the tree. They are known to attack stressed, weakened trees instead of the healthy trees that the invasive shothole borer attacks. So very important to be able to distinguish between the two particular insects and their fungi. So this is actually foamy bark canker disease, and this is what it looks like, and it is brought on with the oak bark beetle there. And the symptoms include a wet discoloration and oozing from the bark. And unfortunately, it's not noticeable year-round. There are definitely times of the year when the foamy oozing would be noticed more than not, and that's during the times that the insect is most active in the springs. If you were to cut a limb off a tree that's been infected by the foamy bark canker, you would actually see all that black there is the actual infection. And again, the other view there on the bottom right is just a section of bark that has been cut away so that you can see the infection of the Geosmithia fungus. Pine bark beetles. So it is not known that invasive shothole borer is attacking pine trees. As of yet, they have not identified it attacking pine trees, But the reason that I show this particular slide and that I just talk about this is because these insects look very similar to invasive shot-hole borer as well, but more than that, it's their signs and symptoms on the tree tend to look extremely similar. One of the best ways to be able to tell the difference with your bark beetles and your ambrosia beetles is that if you're dealing with a bark beetle and you remove the bark from the tree, you'll actually see channeling and galleries in the cambial tissue of the tree, where when you're dealing with an ambrosia beetle and you remove that bark, what you're going to see is just a hole that goes into the xylem or sapwood of the tree. So it's a very distinct difference of how they feed, even though both cause significant damage to water flow and nutrient flow up the tree. So this is just another example of a signs and symptoms that look very similar, but definitely a very different species of insect attack. These are the other very common ones that we get confused with here in Southern California as far as the type of activity and symptoms that they display on trees. One of the biggest ones that is confused is the fruit bark beetle, and it's because it does attack our stone fruits, which avocado tends to fall into that category. And why is it important? Because, again, invasive shot-hole borer attacks healthy trees, and it spreads fungus to kill the trees with the insect activity itself. It also is able to expand its populations much faster in that particular circumstance. So the fruit bark beetle is not associated with any fungus. Basically, it is just a bark beetle that is boring into the trees and, again, feeding on the cambial tissue of the tree. So it's very, very important that we correctly identify, I say that so many times, correctly identify what we're dealing with. Anytime we're out in the field, it's extremely crucial. This is actually just a fungus that is known to be found on avocado trees as well. I bring this up again because invasive shot-hole borer attacks avocado trees, and that's one of the biggest focuses right now, trying to figure out what we can do to help with those attacks. So what is so important about this particular situation is that if you actually removed some of the bark surface and looked under there, you would notice there is no entry or exit hole with this. This is just a fungus, and so when we're doing treatment for trees, we want to make sure that we are doing a thorough inspection and identifying properly. So if you're unsure, I say it time and time again, take samples. If it's on a tree species that is not on the reproductive host list, definitely take samples and send it in, because it is so important at this time that we monitor this. There has been some talk recently that they are actually wondering if this will actually go into our agricultural crops, not just into our avocado trees. And so they need to monitor it, and if you have any questions, you can always get in touch with your local extension office on how to take those samples. So this is the code that you will need to do if you're going to submit for ISA continuing education credits. And again, I thank you for your time. This is Christy Richter. Please feel free to reach out at any point if you have any questions, if there's anything I can help with. I'm happy to help. Have a great day.